The first step of the method is to clean and dry eggshells, breaking them into even-sized pieces and washing out all of the inner membrane. This ensures we are measuring just the shell of the egg, making sure the test is valid. The next step is laying out all of the materials to ensure everything is ready to begin. We need to measure and record the initial mass of each eggshell. To do this, I am using a digital scale, which acts as a balance, measuring the eggshell's mass in grams. I ensured each eggshell had the same mass of 6 grams. This is to make sure this experiment is a fair test by controlling every variable except the independent. The next step is to prepare the solutions with different vinegar concentrations. Using 3 identical glasses to remove bias, I prepared each solution. For the first glass, I used the measuring cup to pour 250 milliliters of room temperature water. This is the neutral control and has 0% vinegar, meaning no acidity in the solution. The next glass, I poured 125 milliliters of water and 125 milliliters of vinegar. This means the solution is exactly 50% vinegar, representing the midpoint of the 3 solutions. It will have a higher acidity level than the first glass, but lower than the third. In the final glass, I poured 250 milliliters of vinegar inside. This is 100% vinegar and therefore has the highest acidity out of the 3. Here you can see the equal volume of each solution into labelled glasses. The next step is to take images and videos of the initial eggshells. This isn't so helpful for recording the loss of mass, however, it will help us to see clear physical and structural changes that occur due to the chemical reaction. The next step is to place 1 eggshell of equal mass into each clearly labelled glass, ensuring they are all completely submerged, and begin the timer. The next step would be to record observations at regular intervals. This includes taking photos, observing bubbling, texture change, and any other visible changes to the shell. I recorded and observed the shells after each hour in order to provide progression photos for my investigation. As you can see, after hour 1, both the second and third glasses are visibly bubbling, showing signs of a chemical reaction, whereas glass 1 has no visual change. Here is my observation after the second hour. After 4 hours, I removed the shells, taking them out carefully to not affect the results. The next step is to measure and record the final mass of each shell. As shown through these images, solution 1 lost 0 mass, solution 2 lost 1 gram, and solution 3 lost 3 grams. It is also important to take photos after the eggshells have been removed from the solution. This is to compare with the before photos and look for visual changes and structural degradation. In order to ensure reliability, I repeated the exact same experiment 3 times. This provides an average loss of mass for the eggshell in each solution and creates a more consistent, accurate, and trustworthy experiment overall. This experiment is a fair test as it aims to eliminate bias by controlling all variables except the percentage of vinegar in each solution. The experiment is also valid as it properly tests the hypothesis, showing that higher percentage of vinegar will result in greater mass loss.